Welcome to lesson 2.4 using postulates and diagrams. In geometry, rules that are accepted without proof are called postulates, or you may also see the term axioms. Rules that are proven are called theorems. Postulates and theorems are often written in the conditional, that's the if-then form. Unlike the converse of a definition, the converse of a postulate or theorem cannot be assumed to be true. So we've already learned 4 postulates in this class, the ruler postulate and the protractor postulate, which we won't really use much. We just use them to illustrate the idea that if I give you a ruler or I give you a protractor, you assume them to be correct measuring tools. And then we learned the segment addition postulate and the angle addition postulate. We're going to learn a number of new postulates. Now, these are called postulates 5 through 11 in this book, but that's because they're the 5th, 6th, 7th, 8th, etc. postulate introduced. Not every book will call them the same numbers. So when you're using them in a proof, you don't write postulate 5 or postulate 10, you actually write the idea. So postulate 5, through any 2 points, there exists only one line. So I can make any 2 points, and through them, I can draw a line. That's postulate 5. Postulate 6, a line contains at least 2 points. Because if you only have 1 point, you have a point. So once you put a second point, you have a line. If 2 lines intersect, then their intersection is only 1 point. Through any 3 non-collinear points, there exists exactly one plane. We actually talked about that a little bit in our definition of planes in chapter 1. A plane contains at least 3 non-collinear points, because if they were collinear, it would be a line. If 2 points lie in a plane, then the line containing them lies in the plane. We talked about that again in chapter 1, where we talked about if we had a plane and a line that intersected that plane, the point of intersection, or the way we would define the intersection, was the entire line. And if 2 planes intersect, then their intersection is a line. We actually had that on your chapter 1 quiz. So we have actually been using, as I said, many of the postulates in 5 through 11 in previous classes. One way to graph a linear equation, for example, is to plot points whose coordinates satisfy the same equation and connect them with a line. Postulate 5 guarantees that there's only one such line. A way to find the common solution of 2 linear equations is to graph the lines and find the coordinates where they intersect. That process is guaranteed to work by postulate 7. So we've dealt with these ideas before. We're just putting them into formal postulates. So we're going to go back and, first of all, I'm going to quit the fact that my printer keeps bouncing there, and go through which postulate justifies each statement. This is from prior exercises. So D is in the interior of ABC. So what we're saying here is we have an angle A, B, C. And we have a point somewhere in the interior. So we could draw a ray BD. Now it's somewhere in the interior. It isn't necessarily going to create an angle bisector, but we know ABD, the measure of this angle, and DBC is going to be equal to the measure of the total by the angle addition postulate. Same thing with points. If M is somewhere between X and Y, then we know that XM plus MY is going to equal our total XY, and that's the segment addition postulate. And which postulate justifies the statement? Find the length of MN if N is between M and P. So if the entire thing, MP is 6x minus 2, Mn is 4x, and MP is 16. Okay? So 6x minus 2 is equal to the entire length of 16. I add 2 to both sides. I get 6x equals 18. X is actually equal to 3. They want me to find the length of MN, so 4 times 3 is actually 12. We had problems like this in chapter 1. So we're going to go back to our postulates, and we're going to have to state the postulate illustrated by the diagram. So we have 2 lines here, and they intersect at a point. So you don't have to remember the postulate name, but obviously we're illustrating a picture of if 2 lines intersect, then their intersection is exactly 1 point. Here we're showing that if 2 planes intersect, their intersection is a line. Use the diagram to write examples of postulate 9 and 10. So postulate 9, plane P contains at least 3 non-collinear points. So if you don't remember what the postulate 9 is, you can go back and look, because as I said, I'm not going to ask you. A plane contains at least 3 non-collinear points. So we could say plane P contains points A, B, and C. Okay? We can't say anything about plane Q because we only have the 1 point labeled there. But let's say they had a point here labeled D and a point here labeled F, then we could also say plane Q contains points D, A, and F. Postulate 10. So if you don't remember what postulate 10 is, go back and look. If 2 points lie in a plane, then the line containing them lies in the plane. So lines A and B, points A and B lie on line N, and they also lie in plane P. So line N is in plane P. Use the diagram in example 2, which postulate allows you to say that the intersection of plane P and plane Q is a line. It's postulate 11, but as I said, I'm not worried about you remembering postulate 11. I would say something like, what can you use this diagram to tell you about planes that intersect? So you could actually say plane Q and plane P intersect in line M. Use the diagram in example 2 to write examples of postulate 5, 6, and 7. So once again, let's go back, because I don't expect you to have that memorized yet. Through any 2 points, there exists exactly 1 line. So through any 2 points, so between B and A, there exists exactly 1 line. Okay, postulate 6. I'm going to keep going back so that you will make sure you remember them. A line contains at least 2 points. Okay, so line N contains points A and B. And 7 was about that 2 lines intersect at 1 point, so M and N intersect at point A. When we interpret a diagram, there are things that you can assume and things you can't assume. So here you can assume that all the points are coplanar. You can assume AHB and BHD are a linear pair. You can assume AHF and BHD are vertical angles. You could also assume AHB and FHJ are vertical angles. A, H, J, and D are collinear. You can see that AD bisects BF at H. It also intersects, not bisects. It also intersects CE at J. Even though it looks like you can draw a straight line through G, F, and E, you can't assume that you can. BF and CE look like at some point they'll intersect, but maybe they do, maybe they're parallel. You cannot assume anything. You can also not assume that they don't intersect. You cannot assume that BHA is congruent to CJA. We will learn some properties later about parallel lines, and if these lines are parallel, then there were some things that we can then prove, but we don't have any parallel line markings here. And we can't assume that even though something looks like it's perpendicular or intersects at 90-degree angles, that that's true unless it is marked. Sketch a diagram showing TV intersecting segment PQ at point W so that TW is congruent to WV. So they drew a line here, they drew a segment, and then they put the point of intersection and they wrote congruence marks. Okay? Note that the picture was drawn so that W does not look like the midpoint of PQ. Also, it was drawn so that PQ is not perpendicular. Okay? So it was drawn that way. It's not supposed to look like that's the midpoint. Even if it is, don't assume that it's also a midpoint of PQ. They didn't tell you it was. They told you just that TW is congruent to WV. Perpendicular figures. A line is a line perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line in that plane that intersects it at a point. In a diagram, a line perpendicular to a plane must be marked with a right angle symbol. You'll also notice this is a definition since they're using the biconditional statement if and only if. So interpret a diagram in 3 dimensions. Which of the following statements cannot be assumed from the diagram? A, B, and F are collinear. We can assume that. E, B, and D are collinear. We cannot assume that. AB is perpendicular to plane S. AB is perpendicular to plane S. We can assume that because there's a 90-degree angle mark there. CD is perpendicular to plane T. We cannot assume that because there is no marking. AF intersects BC at point B. We can assume that. In questions 3 and 4, refer back to example 3. In the information stated, PW and QW, if the given information stated PW and QW are congruent, how would you indicate that on the diagram? So that was this one here. You would have 2, since you already used these for congruent, you would need to use 2 lines for PW and QW. Okay? You can't use 1 congruent marks because you've already used that for TW and WV. If you used only 1, you would actually be saying that PW is congruent to WQ and that they're also congruent to TW and WV. Name a pair of supplementary angles in the diagram. So there's a lot here. TWP and PWV are supplementary because they form a linear pair. So there's a lot. So there's a lot of different ways you could say that, but you need to say they form a linear pair, and then a linear pair is supplementary. In the diagram, for example 4, can you assume that plane S intersects T at BC? Well, it already says yes. Let's look at this. Can you assume that plane S intersects T at BC? Yes, you can. Explain how you know that line AB is perpendicular to line BC because of the 90-degree angle marks. And if 2 lines intersect and form a 90-degree angle, then they are perpendicular. It's the definition of perpendicular. Use the diagram to write an example of postulate 7. Well, you may not remember what postulate 7 is, but line M intersects N at point F and no other point. So that's the postulate that says if 2 lines intersect, they intersect at only 1 point. So now we're going to decide whether the statement two planes can intersect in exactly one point is true or false. And especially after our quiz, you should be able to get that it's false because they intersect in a line. Use the diagram to determine if the statement is true. The intersections of plane M and N is points B, E, and H. That's false. The two planes intersect in a line. Yes, the line contains points B, E, and H, but it's a line. G, H lies on plane M. That is true. So using the diagram to determine if the statement is true or false, A, B, E, and H, E, D are vertical angles. No, that's false. Here are the pages which your homework comes from.